where my thesis comes in. I do this in...
Have you ever had a delicious pizza? Very hot, with a lot of melted cheese. You are salivating, and when you take a bite, you feel it's tasty. This flavor of deliciousness is a real taste, considered as one of the 5 tastes. It is known as umami, a Japanese term that literally means delicious in Japanese. And umami is mediated by a molecule, glutamate, which is the molecule in our brain for transmitting messages along roads that are neurons. In each of our brains, we have 100 billion of these neurons, nearly the same number as stars in the Milky Way, in which glutamate moves. To prevent traffic jam on this neural road, we have synapses. And synapses are as checkpoints when we find the receptor of the glutamate that have one job only: collect the glutamate as a message and transmit the information to the right place. This family of receptors is divided into 8 members. And I'm looking for the 7th number of this family because they are like blocks. They are associated 2 by 2 to be functional. And the number 7 glutamate receptor, it can lead to diseases if it's poorly regulated, like addiction. Then you eat too much of this delicious pizza without moderation. But how can we develop treatment against diseases like addiction without knowing exactly where these receptors are? This is where my thesis comes in. I do this in 2 steps. First, I develop tools to study the behavior of the receptor. Secondly, I use it to localize the receptor in the brain. I'm like an inspector who is trying to find someone based on a fingerprint. How do I do this? I study my glutamate receptor outside the brain with methods involving fluorescence energy transfer. A simple yet brilliant concept. I put a green light on in the left hand of the receptor and a red light off in the right hand. Then, when you give synthetic molecule to the receptor, the hands come together to receive it. The energy of the green light is transferred to the red light. Red light on equal message is taken. So far, I have identified molecules that specifically react with our receptor. And these fingerprints will be tested in different regions of the brain. So that's the path I take to paint the map. And this map allows me to reach the stars that contain our glutamate receptor in our magnificent Milky Way.